Hello and welcome to this short video on the 2025.1.1 release of GLOBEClaritas. Let's cover the key features of this new release, some of which are under the hood but do help users in terms of managing systems, etc., and some of which is a bit more interesting for you guys. So anyway, the first thing I'm going to start with is the new virtual Python environment that we've enabled. So previously with older versions of Claritas, we utilized the standard Python environment for the operating system, but because we were dictating what versions of some of the Python libraries that we were installing needed to be, that might well conflict with other applications on the system that also use Python or the same Python libraries, and obviously that becomes problematic for users. So by setting up our own virtual environment, it removes that possible conflict between our software and other software. Now, to start the environment and to access Claritas software, we now need to type CL start in the terminal window, and you can see we then say we've started that 2025 environment started, and then we need to use Control D to exit that environment once we're finished, and then we type launcher to start the Claritas launcher. And so then anything it's using in the way of Python applications is picked up from within the local Python environment. And to just show you what that looks like, if we go to cd opt Claritas current lib Python 3.6 in this case, because we're on a RHEL machine, so it'll be the relevant version of Python 3 that you can have. Packages and ls, you can see we've then got all the different Python applications that we use, from Keras reprocessing through TensorFlow, PyQt5 and NumPy, Matplotlib, etc. So all those packages sit in there rather than being in the operating system environment, so that should make life easier for you to manage your Python requirements for both for Claritas and for the operating system or other packages. They should be less likely to conflict. The other thing to note in terms of operating system sort of stuff is that for this release we are supporting RHEL 8 and 9 and its equivalents, which are Alma Linux 8 and 9 or Rocky Linux 8 and 9. Obviously there's no longer a Community Enterprise or CentOS version of the Red Hat OSs, so that's why we've moved to Alma Linux and Rocky Linux going forward. And in terms of the Ubuntu OSs, we're supporting 22.04 and 24.04 long-term support versions, so those are the ones to use. And the other thing in terms of operating system or packages that we're utilizing, it became apparent towards the end of last year that there were some issues with the MPI-CH libraries that we used to use for MPI processing in Claritas. Seemingly the people who managed the packages had built the latest builds without actually removing some debugging information from the software or from the libraries, which meant that we were seeing errors in Claritas that were problematic. So we looked at what the best options were and decided that we would basically move from using MPI-CH3 libraries to using OpenMPI. There's no real big difference in terms of for the user. There is one subtle change. There's one subtle change that you need to be aware of to the MPD host file, and I'll sort of try and demonstrate that for you. So I'll find a simple MPI start end job to demonstrate that with. So you'll see that MPI start is the same as it was before, as is MPI end, which has no parameters in it. If I click on run, come up with number of calls information, which again stays the same, but the mpd.host file, if I click edit on that, you can see in the old, under mpitch, the syntax for the information in this file would be machine name, colon, and the number of calls available. With OpenMPI, the syntax is machine name or localhost space and the number of cores. So in this case we've got localhost space 4 rather than colon 4. And that's the only real change that you'll notice, and something you'll need to be aware of when you run your MPI jobs, that you might need to update your existing MPD hosts file. Run OK, and the job runs acceptably. So those are the sort of key changes in terms of system level stuff. What I'll do is open up the release notes just so they're on screen. So we've discussed the improved Python environment, we've discussed the improved MPI support and the updated operating system support. So I'll next talk about the data visualization and QC. I'll move to a different project. 2D Marine, go to Seismic Data Viewer. There's a new button on here called Size Viewer Beta, so this is using a Python based seismic viewer. We put out some short videos last year demonstrating some of the capability, and I'll just sort of give you an overview again. So if I click on Size Viewer Beta, it'll bring up the file selection widget, and then we can take those couple of data sets, sorry. So if I take those two which are pre-stack, we'll look at some post-stack data shortly. You can see we've got the data displayed, the variable density display here. I can toggle back and forwards. If I want to change the settings, I can go to the settings menu, application settings, and change, for instance, the number of gathers I'm displaying at any one time. Stretch the display out if I want to. So that's our 3 shots displayed. As per the previous video we put out, we can also, rather than the standard toggle sort of comparison method that we've had in Claritas for a long time, we can also use the split option and then swipe the data over the top just to see where the differences come in, and unsplit to stop that. Difference isn't implemented yet, but that will be coming later. I can click on the zoom and zoom in over an area of the shot gather and show all panels for that and look at that more closely. I can also shrink the display if I want to and stretch it out as well. The other thing we have available in here is a number of analysis functions. So again, we've got the full list of functions that we've had in the previous viewers, but not all these are implemented yet in this version. So we are backfilling the rest of these displays as we go. So as we start releasing betas for 2025.2, you'll start seeing more of these applications available. So for instance, if I click on FK Spectra and then I've got FK Spectra display. Again, with the FK Spectra windows, we haven't implemented the mute picking or filter picking options yet. That will be added at a later date as well. And text header, at the moment it only displays the standard Claritas 240 bytes trace header. We will begin to add in extended trace headers again over time so that you can view those as well. Yeah, so that's all the analysis tools there. Again, we can apply some level of processing. So if I click on that, choose the processing module, you can see what we can choose from. So we can apply geometry to the data, AGC balance, filters, debias, NMO, phase correction, or static shifts as required. So for instance, I'm going to put a balance on these 2 shots, and then when I display them, they're sort of closer together. Then if I want to change the amplitude or the panel settings to make the display a little nicer, I can change the amplitude range, for instance, to get them a bit closer together. I can change the height scale, vertical scale, etc. if I want to. I can also swap to variable area wiggle if I'd prefer to look at the data in that form. And I'll just quickly show you some stack data as well, because we can look at stack data in this application as well. So again, we've got our data sets. We can again use the analysis window. So for instance, I could take an autocorrelation zoom through here, change the settings to make the window bigger, the autocorrelation window bigger, all panels, compare those. I can also swap to variable density if I want to. And if I click on the color bar in any of these displays, I can choose from a different color map that I might want to use to look at the data. So for instance, in this, I will go to the black, white, red, so I match the rest of it. So we will begin to continue to backfill functionality that exists in the other viewers into this viewer, so that hopefully by the end of the 2025.2.1 release, we'll have a fully functional Python viewer that does everything that the existing viewers do, and also adds in new capability like the split screen view mode, such that we're able to sort of add value and improve the viewer and experience for the users as we go through. Next thing I'm going to look at is the new surface consistent decon application. So I'll show you a job flow. So the new module is called SC Spec. It's one of our modules that handles both input and output and the processing flow that we want. So it will be like SCAMP and our migration modules, in that it will be a single module within the processing flow to run this surface consistent deconvolution. So we provide an input data set. In this case, we're going to use our surface consistent amplitude data. Our output, if we've got a separate factor file, we can read that in, or we can output the factors if we want to. So we can basically store the factors as part of the processing flow, as part of the flow, and use them later. In essence, much like we were with the old surface consistent decons, where we could output effectively the decon operators and then read them in and apply them with the decon WAC module separately. So we could do some conditioning to the decon operators and then apply them. In terms of applying the surface consistent decon, we got the choice to apply only to the shot and receivers, or to all. So we can apply it to shot and receivers, or we can apply it also to the offset, CDP and azimuth factors that are created. We've got control over the operator length and the gaps that we might want to use. Number of factors to estimate. So we might find on a certain data sets or on certain systems, if we've limited RAM, that we need to cut down the number of factors. So the default's 10. If you're struggling to run it on your system, then you might want to decrease it to 5. That might help things. And then the resolution of offset and midpoint are also specified, as well as azimuth. And then there's the option to plot QC windows at the end, so you can look at some of the factors or display the information about the surface consistent decon in a simple display, so you can look at quality of the result. Won't run the job interactively because it takes a little while to run, but I can show you some results on the data, and I'll probably go to the 3D land tutorial for that and seismic data, and we'll use the old seismic viewer because it's got some of the functionality that's not available in the newer viewer. That's quite useful for this. We've got our input data, which is after surface consistent amplitude correction, and then our data after surface SC spec, so the surface consistent decon. So if you look at the input data, there's a little bit reverberation, lots of, I guess, ringing going down through the data. And when we apply the SC spec, we sort of collapse the wavelets, remove some of that ringing, make the gathers or the data a little bit easier to understand what's going on and interpret. So it's looking quite good. I can maybe run a frequency spectrograph over a portion of the data. Like that, click all panels. So you can see that we've got the red is the input surface consistent amplitude correction, and then the blue is the SC spec result. So you can see we've got a broader spectra, frequencies going out further, just a nicer looking amplitude spectra for that data. And again, if I do a seismic data zoom, say through there, so that's our input surface consistent amplitude correction. That's a spectral after surface consistent decon. So again, you can see you're cleaning up the wavelet, making things a little bit more easy to interpret. So I think that's quite a nice result. Next thing we'll look at is some improvements to the geometry application to sort of try and make life easier for our users who are working with ultra high resolution marine seismic data sets. So if we go to a UHR test data set we have, go to geometry, select the geometry file. We have our data, we're displaying pegs and receivers and shots in the data. And so we go to the hit points menu and we select make automatic picks, and in here we've got a new parameter calculate from and a new option within that form. So if you click on that, we've got options to basically calculate the hit points based on midpoint location, which is the standard or default one, which works well for marine and land seismic data, in that we put the hit points in the center of the midpoint cloud, and that's where we want to run our CDPs through. Or we can use pegs or shot points. For UHR data sets where we're trying to track the ship track or sail line closely and keep the CDP bins within typically something like 0.5 meter to 1 meter of that ship track. If we use shot points, add a few more hit points in there, click OK, then we can hit those hit points. The first hit point will be halfway between the farthest offset and the nearest offset, and that will be based on the midpoint cloud, but all other picks after that will be based on the shot points. Click on that so you can see that. So we've got that first pink, and then we've got all these over here. If I do a quick zoom through here, you can see how those, so the red squares are the shot point locations, blue crosses are the midpoint, are the receiver pegs or receiver points, and then the sort of circles on top of some of these red squares are the hit points for the trace binning, and shows that those hit points are following the ship track nicely. I'm going to turn the receivers off just to tidy up that display and just leave us with the sources and things. And then I'm going to go to make and create a wiggly line CDP. Run that, not losing any traces, which is great. And I'm going to plot my CDPs on there. So this is my bin centers for my CDPs, which are the green plus signs, and you can see they're tracking nicely through that ship track. So in terms of when you're running processing projects for your clients, if they've got a requirement, the CDP bin centers are following that ship track or within 1 meter to 0.5 meter of the ship track, then this update to the geometry application should make your life easy and allow you to achieve that requirement for your client. And then the final thing I'm going to talk about is some work we've done on creating a new module called Wang Shift. So Wang Shift is around optimizing your multiple model before the adaptive subtraction. It uses pretty much the same technology as the Wang sub module without the subtraction part itself. And what it's looking at is trying to match the model as close as it can to the input data. But where Wang sub doesn't allow the model to be shifted up the trace, so to lower times, Wang Shift does allow this, particularly useful again for UHR data where the cable control's not as good sometimes, and the toe depths are very short. So where that a relatively small variation in the cable toe depth on those UHR data sets leads to a big change in the character of the water bottom in the gathers and therefore the multiple model. So Wang Shift allows the data to move, the model to be moved up, and also allows that shift to be unique for each trace within the gather as well, although it gives users control of that. So if I click on job flows and bring up a job flow with Wang Shift in it, so that's the Wang Shift module. So again, we define the number of the folder data, the model name, or the name of the header that contains the SRME model, and then we've got control on the maximum shift to apply, and that can be positive or negative, i.e. pull the trace up shorter time or push the trace down to a longer time. And also the jitter parameter says that I'm going to allow the amount of shift to vary between each trace. I can set it to 0, so each trace has to have the same shift, or I can, in this case, I'm saying I'm allowing a 0.5 millisecond difference of shift between each trace. So what we hope that does is optimize our model that then allows the Wang sub or Monk sub modules to be more successful in adaptively subtracting the model from the input data. And then some examples of that, if I click on View Seismic. So I have 3 panels. I have data with no adaptive subtraction SRME applied, which is this one here. I have data with just Wang subbed, no Wang Shift applied, which you can see does a reasonable job. And then I've got with Wang Shift applied as well. And you can see that that's having a positive improvement on the amount of subtraction that's happening to the data. If I zoom in through there, all panels, that's the Wang Shift result, that's the Wang sub. So you can see there's a little bit more present. So yeah, so Wang Shift can be useful to sort of tidy up and give you a little bit more aggressive adaptive subtraction on your seismic data. Worth giving it a look and see how it might positively affect your adaptive subtraction of stubborn multiples. So we've got a whole bunch of obviously bug fixes and small improvements to the software as well. So there's a lot in the new release, certainly worth playing with, and we'll obviously keep you updated as we deliver betas for the 25-2.1 release as we move towards that release in August of this year. But again, that will be sort of improvements to the new viewer, adding in the functionality that exists in the old viewer and adding new improved functionality as we go forward. So hopefully you'll see a gradual improvement on that. We should see more in terms of the analysis tools appearing in the first beta in about 3 weeks' time. Any questions or comments on the new release, please do let us know. We look forward to hearing from you. Thank you, and enjoy using the new version of Claritas.